Okay, so here we go with the college algebra final test review. I have my little sticky notes stuck out. There's a couple of these that are going to be graph problems that I don't have printed out, and y'all didn't want to see me draw all of these graphs. So I'm going to go back to the questions we've done previously that I've put into my handy dandy chapter 6 binder. And this is only the chapter 6 binder. And I have binders problems, so when we get to those, I'm going to hop over to these and we'll talk about it on them because they shouldn't be too bad. There's one of them that might be up, but oh, here we go. Let me share my screen. All right, so there's should be 25 questions. Let me double check. 25. They're going to be just like my math lab. They're not going to be multiple choice. And let's go. So first thing on this one, you need to remember that natural log of e equals 1 or e to the natural log equals 1. So the answer to this one is just, where do I want to put it? 19. Maybe I should highlight these, but I don't want to choose so much. Okay. Now then we go, and all of these are going to be jumbled up on all of yours different ways, so just be excited. All right, we're going to go ahead and do this composite function. This composite one, they give us numbers, so we're going to do g of x first. So we're going to have 2 times 4 equals our 8. And we're going to put this 8 here, so we'd have 5 square root of 8. That's when I really want y'all to have these calculators. 5 second square root of 8. So our answer would be 10 square root of 2 on that part. G of f of 2. So first we're going to put x in for our f function, so we'd have 5 square root of 2. We're going to go ahead and put that into this one. So we'd have 2 times 5 square root of 2, which is going to end up being 10 square root of 2 as well, because 5 times 2 is 10. All right, then we have our f of 1. So we're going to have 5 square root of 1, which would be 5. Then we're going to put that into this one, 5 square root of 5. That doesn't reduce. So that would be that answer. Then here we'd have 2 times 0 equals 0. And then we'd do it again. 2 times 0 equals 0. All right, we have the natural log of e to the 21st power. Remember that this equals 1. So our answer is 21. And I have all of my little note cards from previously right over here. So if I have them, you probably should just go ahead and get them out. Okay, we're going to use this one on this because we have an e with a power. So I have 2x plus 7, because that was my y, equals the natural log of 15. They want us to solve this for x, so we're going to subtract our 7. So I'd have 2x equals the natural log of 15, subtract 7, divide by 2. So x equals the natural log of 15, subtract 7, divided by 2. Remember, I can't actually do 15 subtract 7 because the 7 does not have a natural log with it, and we don't actually subtract them ever. have log 7 of 6, log 6 of, so on this one, what I'm going to say to do is use your calculator and do the base change formula. So I'm going to write it on this and use my calculator. So I'm going to write calculator here though. But to be able to type this in, remember the top number or the big number goes on top. Times the natural log of. And if you notice on this, these are going to end up canceling out anyway. But you're going to have fraction, natural log of 6. And I'm going to go back up there because fraction, natural log of 6, close that parenthesis. Natural log of 7, close that parenthesis, times fraction, natural log of 2, 4, 0, 1, close. Okay, here they want us to solve this. I'm going to use this one. So my x is 11x. So 11x equals a and y. So this would be 11x equals what is 3 to the 4th power. I think it's 81. And then to solve, we divide by 11. That will not simplify. X equals 81 over 11. Log 8 of 1. Remember, anything that has a 1 right here, to be able to get that 1 when we do like our exponents, anything raised to the 0 power is 1. So any log that has this 1 after a base equals 0. All right, express as a single logarithm. On this one, we're using this rule as well as that one with the exponents that we bring them to the front. So since both of our bases are log 7, we're going to have log 7, and they're going to, since it's adding, we're going to have this multiplication one. So we're going to have u, and now that front number is the exponent. We're going to have v, and that front number is an exponent. And that would be it. And all my little things everywhere. Okay. This one, they're going to want us to express it as a single logarithm as well, or do they want us to solve it? I notice they both have the same base. I can rewrite these both to be let's just do that first. So I'd have 1/2 log 9x subtract 2 log 9. 3 equals 0. Then I'm going to do what I did up here, except this is a subtract here. So now I'm going to use this one. So I'm going to have log 9 x to the 1/2. And then I'd have this over 3 squared. If I put it beside it, but this is a subtract one. equals 0. I do believe I'm doing this one wrong. I'm having a brain fart. I'm sorry. Okay. So 2 log 9, 3. I can rearrange that to be this. Why didn't I write the directions down? I did this last week and I don't remember. Two times natural log of 3. Delete that. Over natural log of 9 equals 1. So all that is 1. So I'd have, I'm going to like box this off. I don't know. But I'm going to leave it there for a second. Log 9x equals 1. So then I can use that information to switch this. So I'd have my 1 is my y, my x is x, so x equals but this 1/2 would be here, so I'd have log 9x to the 1/2, which is going to be the square root of x, because anything raised to that half power equals 9 to the first power, so the square root of x equals 9, so then x equals 81. I know I did this a different way last time. So sorry. I think I probably just did 3 squared is 9 and 1/2 x because. So another way you can do this one, since we're on this kick, but this is definitely not the way I would do this one. So like, don't look at this. Since these are the same, and I should recognize this first, this would be x to the 1/2 equals 3 squared, which is the square root of x equals 9. So to get rid of a square root, we square it. So we'd have x equals 81. And this is the easiest way to do this. You know, the last way I do it, because I'm a complicated soul. So I want to go ahead and do 11 and 13, and then I'll find 10 and 12 in the book. So, or in my binder. Okay, here we're trying to get these bases to be the same, so I know that 2 cubed equals 8. So I'm going to have 2 to the negative x equals 2 cubed. So I have negative x equals 3. X can't be negative, so x equals negative 3. Five to the x power equals 4. I can't do that. They don't have the same bases, so I'm going to use this to be able to find it. So I'm going to have log, my a is 5, my y is 4 equals x, and I'm going to check and see if that works in a calculator. If it doesn't, that's the answer, and I'm pretty sure this is the answer now that I've said that. Natural log of 4 over, because if they say exact answer, they don't want this decimal stuff. So if they say exact, leave it like this. And I'll write that exact. No decimal. Okay, let me find 10 and 12. Graph the inverse of a one-to-one function. One-to-one functions was section 2. And I remember what they look like, so I should be able to get you a pretty close one. All right, so your one-to-one function is going to be like these two problems. So we're going to find the one that mirrors it over. So I think it's this exact problem right here. It'll have the different numbers, but it's the squid looking one if they're all the same. So that's what number 10 is. And then 12, match exponential graphs to equations. That was 6 point. This one. I should have one where I've wrote on this as well. Okay. Now that it's all good and messed up in my binder. All right, so here's one where I wrote on it, and then here's the one where I printed it out so it looked nicer. So it's this exact problem, and you're going to be dragging and dropping them into the matching ones. So remember that this is your normal exponential graph one. So we have 7x. You can take this information, knowing that this is the normal one. That's normal 7x subtract 1. So find the one where it goes down 1. So we're looking for the graph like this, but it goes down 1. That has a negative, that's a negative in front of it. This is 7x subtract 1. So it's going to still be the graph that has like this, but it's moved 1. Now that's the only ones that are like this. So now then you're going to have to flip something. So remember when we flip across the y-axis, the x is the negative. So we're going to do this one. So we'd have this flip across y. And you may print this one out because I kind of wrote them on here. So we flipped across y here. Now then let's look for our graphs that have a negative x. So that one has the negative x, so we know we're going to move it. That's a positive one. So we're going to have it move to the right one. Then, okay, so we're done. These 3, these 2. Then our next ones are all these. So negative negatives. And I don't think I put the right negative on this one, so that's probably wrote wrong. Negative 7x. Oh, this is our negative graph right here, and there's only one of them. So if this is the normal, one negative is just going to flip it one way or the other, but both negatives. So this is like super confusing me explaining this, but I print this out and it's in your notes for this problem. And this should greatly help you. Slide these back in here. Okay. That looks like good, but I'm going to highlight these. And both of them are in your notes from previous sections. Determine whether the function is one-to-one. So that's where no repeating range or domain. So you can't have a repeating x value that's x is repeating or repeating y's. So 3, 4, 5, 6, good. 3, 4, 24, 62. Determine whether it is one-to-one. Yes. It is an 1-to-1 function. Log 3 of x equals 4. That's where we use our change to get x alone. So it's going to be x equals 3 to the 4th power. I tend to get these two mixed up over here, so be sure you're paying attention. So x equals 81. The base is always, the little number always ends up being the big number, if that helps. Is the given graph one-to-one The horizontal line test. I should have worded that. Is the given graph a one-to-one function using the horizontal line test? 1-to-1 was 6.2. And these are our one-to-one tests right here. So if you draw that horizontal line and hit it twice, it's not. But if you can draw it once and hit it, it is. So that one's pretty. Using the graph, find the given f values. That's going to be these. So you're going to take the graph and we'll go ahead and use the values they gave us. So they said g of f of 1. So first we go to f, and this is our f function. So when f is 1, because we go by x values, g is, so f of 1 is 0. So then I go g of 0 is 6. So that would be 6. Okay, f of 0 is 1. So g of 1 is 5. Now they switched it. So g's first. So g of 3, 1, 2, 3 is 2. So then f of 2, 1, 2 is -1. G of 4, so 1, 2, 3, 4 is 3. So f of 1, 2, 3 is 0. So just remember, the last one is the one you go to first. Craziest way to say it. I'm going to put a highlight on this one too because we snuck a graph. So you can't just do that one off of this. All right, I'm going to pause this video or stop this one.